Hello everybody. I wanted to show you a little packet tracer, and this is our topology. As you can see, it's the one we've been working with and we will continue to work with. As of late, not a whole lot's changed since the last time I talked to you, which was just a couple of days ago, and I've been slacking a little bit. I've been really busy with work and some other things, so I actually wanted to cover what we're going to go over here briefly. Here is the lab requirements. And right now, in a previous lab, I ran into some issues with some things, and a phone call came in. I had to take care of that. So currently, I have all of this configured. So we're going to implement the Ospf and the Eigrp, and then we will discuss how Eigrp will be the routing protocol for frame relay and why that is, and stuff like that. But I actually have something to show you, which I think is kind of cool. I am going to open a file as soon as I find it, wherever I put it. I am in the middle of doing a very large backup right now, so my computer may run just a little bit slow, so I apologize for that ahead of time. This, ladies and gentlemen, is what I just recently bought. This right here is my rack of equipment. It is what I will use for my CCNA prep, as well as my CCNP prep. It is going to pretty much do everything I need it to do. Now, from the bottom to top, we have a 3640, which is my frame relay switch. This one, and this guy. The very bottom, this guy right here, and the top two routers are 2612s, and this guy's a 2610. As you can see, these three have serial connections back to the frame relay switch. So what I'm actually going to be doing here in another couple days is buying another cable to connect right there. You probably can't see it that well. Actually, I'll zoom in just a little bit. Right here is the serial port, and as you can see, I took this picture turned on. Took it from my phone camera, and so basically from bottom to top, 3640, 2612, 2610, 2612s, 3550s, layer 3 switches, and then we have 4 2950s. Do I need that many switches? No. Actually, these 4 right here are part of my original lab, and then these 2 came with these 5. So if anybody's interested in 2 switches, hit me up. Right now the rack is off for obvious reasons, because it does suck up a lot of power, and I don't feel like dealing with that right now. So when I'm labbing, they're working. As a matter of fact, I have to actually go onto eBay, and I have to put memory. I have to go upgrade to 32 megabytes of RAM on all 4 of them, because the fact that the iOS that I want to run won't fit on the on there, because of the fact that they're so small. So I'm actually going to max out the RAM on all of the boards here in the coming weeks. It doesn't have to be done right away, in the next month or so, because of the fact that I want to get done my CCNA first before I jump into spending any amount of money on any more money on lab equipment. And I'm going to buy a 4th cable, which will turn this guy into this guy. So this will be 4 routers, and the goal at that point would be to take these 2 routers and these 2 routers and connect them to this guy, and then these 2 routers to connect. Well, it'll be the top 2 will connect to this switch, and the bottom 2 will connect to the bottom switch. And what that'll allow me to do is HSRP and VRRP and GLBP for first hop redundancy, to practice those and actually see failover happen, and then eventually I will update the iOS on this guy so it'll become an MPLS switch, and then I'll be doing MPLS on these guys. So I just wanted to show you guys that. I thought it was kind of cool. I am a geek when it comes to Cisco, so that is why I have 11 devices, and I'm actually, where I work, they're getting rid of a rack, and I'm planning on getting that rack for free, as long as everything pans out, and putting this stuff into a rack and getting it out the filing cabinet, which you can see is right here. And you probably can't see very well, but that guy right there is my Linksys router that goes to the rest of the house. And this yellow cable right here is actually that connection to it. So what I actually did was I took that connection out of the switch, and then I plugged it in. There's an Ethernet port right here. Probably can't see it, but there's an Ethernet port right there, and that Ethernet port connects back here. It does actually say Ethernet 3/0/0, but you guys can't see that. But that's what's up. It is all cabled. It's all functioning. It doesn't actually have IP addresses on anything yet. I will configure loopbacks. Everything will be pingable, and it'll pretty much everything will come back here, and I'll set up routes and stuff like that. So it's a work in progress. I just wanted to get the physical stuff put in, and I have. So moving on. So what we're going to do now is we're going to talk about getting Ospf, Eigrp, and frame relay set up. Now I have frame relay partially configured, and it should work in here. Now routing itself is turned off. Now what I'm going to do is this. These connections right here, all of the point-to-point, not the ones that connect back to the cloud, but the ones that are point-to-point between the routers. Those will all be PPP connections, and they will be authenticated with CHAP. So I'll show you how to do that and how to set up a username and authenticate with that and go through that. And I will configure static routes pointing to those IP addresses on the remote router. So anything coming from this network will point to this IP. And what that does is it sets it up so that it'll be a weighted static route or a floating static route. So I'll kill this connection, and then I'll kill another connection, and I'll show you how the routing table will populate the new route, and so you'll have a backup connection. So we'll go that route. But I'm going to pause the video for just a moment so I can get a couple things in order, and I'll be right back. Alright, after playing with it for a couple of minutes, I finally realized what I was doing wrong. It was just I just couldn't remember exactly what I was supposed to do. And this is what I've done. Okay, right here it says, and it took me about 10 minutes to realize this, but knowing Ospf like I do, I should have known. I was thinking about this the other day when I was at work. I'm like, I wonder if I was doing this wrong. What I did was right here, I said, describe and implement layer 3 switching for Ospf. The layer 3 switch is the BDR. And it says that, where else did I say that? And all network devices will have a loopback address, and then they will be reachable by the loopback. Excuse me. So basically what I did was, and it took me a little bit to realize this. Now, I had to do a debug to figure out what I was doing wrong. So basically what I've done is show IP route. And I'll do a show IP route. Actually, it's already there. This is what I did. Actually, let me do a show IP interface brief. This is what I've done. On the switch, you can see that I have a VLAN. So the switch is actually the one doing the routing, not the router. The switch it's faster, the backplane is there for it, it's all on the same thing, or it's all in the same box. It's not going to use, what do you call it? It's not going to use the router to route over the Ethernet connection. So what I've done is I configured a loopback address 23, because 23 just happens to be the main network number that we're going to use. And then this guy right here is 1 because it's router 1. As you can see, router. Well, you can't see router 1. So I used that IP address, and all I did was the loopback, as I advertised the loopback IP address as a /32 into the routing table. Now, I did some verification to make sure that it was actually routing. And what I did is I did a show IP route, and I did a show IP Ospf neighbor, and it shows that it learned the .23, and this is router 1, so it knows layer 3 switches loopback address right there, and you can see that that's the same. It's full on its BDR. See, now that's wrong, because this should be the DR. Oh no, I'm correct. So if you do a show IP Ospf interfaces, right here, it says that the router is the DR. The router is the DR for all of the networks, and that's what I wanted. The way you set that so that you can guarantee that the router will become the DR is you set the interface cost. So I'll do a show run. And right here, the loopback is a priority of 10 on the switch, and I believe show IP or show run. And the loopback on this guy is a priority of 100, and that's what I'm basing it off of. Because once you configure a loopback address and you advertise that in, that's how it'll determine. It'll go either by physical interface IP address, the highest one, or it'll go based on logical. It will prefer logical because the logical is up when the router's up and down when the router's down. So I configured a higher priority for the router, so that would guarantee that it would become the DR, the designated router. What does that mean? Well, basically it means this. Whenever my computer's going slow. Whenever this guy sends an update, well, let's assume that there's more routers, but there isn't. What ends up happening is this is considered a point-to-point network because it's only 2 routers. What will end up happening is on this interface connection right here is whenever a routing update happens, and it goes in depth where it's every 30 minutes there's an update and every hour there's an update. But every 10 seconds, this guy multicasts an update to this guy and says, hey, this is what I know about. Or, hey, are you still there? As long as they're exchanging hellos, then you know that the link is still active and up. So, with that being said, is you can turn around and on the DR, on 224.0.0.6, it's getting multicast updates from the switch. And on 224.0.0.5, the DR is sending updates to the BDR. Now, if this guy goes down, actually the whole network goes down. This design is a little on the bad side, but this is more of a theoretical point of view. If I was to throw another router in here on another network, it would make more sense, because at that point it wouldn't be a point-to-point network, but it defaults on Ethernet interfaces to become a broadcast network. And on broadcast networks, Ospf will automatically elect a DR and a BDR for updates. And because what will end up happening is if it doesn't, it'll broadcast updates to all routers, and that's just a lot of interface bandwidth utilization that doesn't need to be used. So what it does is it elects a designated router. And if you're familiar with the Windows environment, it's like having a domain controller. This is the leader of the group. Okay, this guy says, okay, I'm going to take care of all of your updates, I'm going to take care of all of the information you need to worry about, and everything else, the BDR, the backup DR, what that does is it kind of falls in the secondary command. You know, he's next in line. So if this guy fails, this guy comes over as a DR. But if this guy fails, technically nothing else is going to happen. What do I mean by that? Well, anything that comes out to this section of the network isn't going to work because this router is down. This guy will still route because he's layer 3 switching. And that makes it a lot easier for the internal section. So all this router's got to do is forward packets in and take packets out. So, that being said, now I have configured frame relay to a degree, and I will bring this in here and do config and frame relay. It is supposed to be working. Now it's weird. There's just, I do have DLC set up for this stuff, and it should be routing, but I haven't tried it yet because it's not connected. So on what I'm going to do on this guy right here, serial, click on this guy and serial 001. And as you can see, here's my Ospf stuff. So I have the loopback address configured, and then I have all. Actually, I goofed up. Actually, I had to remove a neighbor statement. So actually, we're going to come in here and go IP or router Ospf1 and type in, and scroll up here. We're going to copy this guy because this is actually wrong. We're going to copy. We're going to paste. We're going to Control A and type in no. And then we're going to do an end. We're going to do show run. I don't know if it's going to work on this, but I'm going to try it. Section router Ospf. Yeah, it doesn't like that. It doesn't know what that is. What this does, this is what they call the pipe command or the grep. And what that does, it allows you to thin out your running config. So instead of having to type in show run and get this to where it takes that neighbor statement out, you would actually just be able to get this output. But this isn't full iOS, so you're kind of out of luck. So, with that being said, now what we have to do is we have to turn on Ospf. Now Ospf is routing, so I should be able to ping from the router this guy. So we're going to highlight this guy, that is 20.2. So we're going to type in ping 10.23.20.2. And I can ping it, so because it knows how to get there. So, and actually I'll do a trace to it as well. Copy and paste. And there, it knows how to get there. The whole point of that, and do show arp, is knowing how to get there. Now see, and let me explain this. Now, if you watched another video, you saw it last time it was doing it, and that's because the router was actually the one doing it. What ends up happening at this point is this ARP only works for directly connected. Okay, so this guy knows about this guy because I have the loopbacks. Now, it's because I had to... getting myself caught up here. I'm getting too far ahead of myself. What I had to do, in order for a layer 3 switch to actually be able to forward packets layer 3 from a layer 2 device to another layer 3 device, you have to turn off the switch port. What do I mean by that? Well, let me show you this. In order for Fast Ethernet 10, which is this guy right here, in order for that guy to forward information to the router and for the router to forward information to the switch, you have to put an IP address on a switch. Well, how does that work? Well, if you are dealing with a multi-layer switch, any switch that can route, or a layer 3 switch, which can also route, in order for that to work, you have to turn the switch port function off on the switch, which turns it into a routed port. In turn, you put an IP address on there that's going to match an IP address of this interface right here. What that does is it allows you to exchange routes. That's how I was able to get the Ospf neighbor relationship to come up. Now, it's formed based on IP address. So all I did was I go in and you just advertise that network. That's all I've done. So according to router 1, it only sees this network to this guy. But because it knows how to get to here, and this device knows how to get to all these devices, there's no problem because it's directly connected. Do you follow what I'm saying? Because this one knows how to get to this guy, and this guy knows how to get to all the other routes. That's how it knows how to get to where it needs to go. Because when you do a show IP route, he knows how to get to 1.1.1/32 because of the fact that it's advertised by 10.23.65.251, which is also show IP interface brief, Fast Ethernet 0/0's IP address. You see that? I hope that makes sense to you guys. It knows about it because of the fact, so you see 10.23.65.251, 10.23.65.251, it learned it. It's a point-to-point connection at this point. But because of the fact that there's routes in here, now I do have IP addresses here, and I could theoretically turn them off. I'm not going to. I don't know if I need them up, but I don't think I do because of the fact that the switch is doing the routing. So, what I could do is on here is do a debug and IP packet. Now that's doing that. Now what I'm going to do, now see how that is 224.0.0.5. It's multicasting hellos. So what I'm going to do now is I'm going to bring this over here, and I'm going to click on this guy, and I'm going to go to the desktop. I'm going to ping 10.23.65 or 10.2. It should ARP. You know what? I know what I did wrong. This is where you're kind of like, As you can see, it's sending updates, and that's working. We know it's routed. It's got that. But that should have worked. Technically speaking. IP config. Okay, it's a different network. It's got them. And it's saying it sees it. Now let's do the same thing with the router. This is how you verify. You do some debugs, make sure everything's working. And let's bring that up and PC1 up again. And we're going to do the same thing. Actually, no, let me do this. Debug IP packet. Let me bring this down just a little bit, just so you guys can see what's going on here. We're going to do this, we're going to do this, we're going to do this. Now, switch is on the left, router's on the right. This guy's on top. As you can see, the switch is receiving, right? So now we should be able to go 30 and .2. See, it's receiving it. Up, there it goes. Okay, I'm just trying to make sure I've got this all right before I say, yeah, we're routing. Alright, so it knows about that one. So we should be able to do 10. See, it sees it coming in. Oh, there it goes. Whew. Had me worried there for a minute. Alright, so now it sees it coming in, and it looks like, if you type in UAll, it shuts off debugging. And UAll. There. Now, that being said, see how this is coming in right here, and it shows that it's going through, and it looks like the router still received it though. So I'm going to config T and type in interface fast0/0.10 no IP. I'm just curious to see if this is going to make any difference. Let's try that one more time. Debug IP packet, and Debug Ip Packet, and yeah, it's just the switch doing. It's just the switch doing it now. Yeah, as you can see, it's not receiving. It's just the switch doing it now. That's exactly what I wanted to see. Yep, we're good. It's just doing that because now it's just receiving routes. It's exchanging hellos with switch 1 here on the router. This guy is doing the same thing. It's sending back and forth hellos, and it's also routing the VLANs. So we have success with that. So I'm going to do you all on this guy and you all on this guy. Being able to do a debug is definitely going to help you if you are not sure on how something's working, especially if you're going to be like going for the CCIE or something like that, or you're going for a CCNP and you want advanced levels of understanding. That's definitely something you're going to want to focus on, is being able to interpret why something's not working correctly. So, that's me. That's my 3-year-old. Well, he'll be 4 in a couple weeks. My oldest son, and this is my wife. This is at Disney World. And, we're back. Okay, now, with that being said, now I'm going to go in here. I'm going to implement IP routing here because I don't believe... Did I set IP addresses on these guys? I did. They should be well working. But I'm going to pause the video for a moment and I'm going to set that up, and I will walk you through quickly how it works. Okay, I have successfully logged into the other switch over here. This guy right here. And what I'm going to do now is I'm going to configure it so that it will be a multi-layer switch. So show IP interface brief, because right now it is not doing that, as you can see. Now it's got a loopback address and no IP addresses, or it's not routing VLANs yet. So what I'm going to do is do this. I'm going to click on this guy. I'm going to come over here, and I'm going to... So it's username Rob, password Cisco, and I'm going to do show IP interface brief, and show you that this guy is routing the VLANs. Now I don't have to verify that they're routing, but the idea behind this is this. Squeeze this all into one screen here. I have dual monitors, which is really nice. So what I'm going to do here is, as you can see, 2.2.2.2, and these are the loopbacks. So what I will do is when I turn Ospf on, that's what I will exchange it as. Now, if you're going to set it up to be a layer 3 switch, you must turn one of the ports that you're going to connect to as a layer 3 switch port, or a layer 3 routed port. So this fast Ethernet 0/1 connects to this FA00. This guy's got to become a routed port. On the router, between the router, this interface and this interface have to be on the same subnet. So it can be the what do you call it? The 10.32.56.1. And what I will end up doing is I will, because that one's not attached to this interface right here, this VLAN 1, I will turn that off on the switch, and I will configure that as the IP address of the routed port and of the router. So I'm going to go ahead and get that kicked off and show you how that kind of works. It's really simple. So what I'm going to do is on the switch port, I know that it's FA0/1, so I'm going to go config T, interface VLAN 1, type in no IP address. That takes it off the interface. At this point, I'm going to go into, this is switch 1, so I'm going to interface F0/1. I'm going to type in no switch port. That turns it off, or it turns the switch from a switch to a switch port, or from a switch port access or trunk to a routed port. So type in IP address is 10.32.56.2 255.255.255.0. No shut. I do that just for the simple fact of I know I turned it on. So I'm going to come back over here to the router and FA00. So I'm going to click on this guy, config T, interface F0/0. IP address is 10.32.56.1 255.255.255.0. And then no shut. Now I don't have to type in no shut, I just do it for the simple fact. Now, what I'm going to do is on the switch, for the VLANs that I know are created on this guy, and I will use this as for reference, I will come in here and I will go interface VLAN 11. I'll type in IP address is 10.32.11.1 255.255.255.0, and then do the same thing for 25. And it actually goes a little quicker once you actually have the initial config in there. And this will be 41. Same thing. Up, up. Just hit the up arrow a couple times. There. Now I have VLANs created on the router, or on the switch. So what I will do is I will go in and I will turn those off on the router. I'll type in interface F0.11 and type in no IP. This is just a quick way to get it up and I'm not turning it off, I'm just turning it off. Or I'm not turning it off, I'm just taking the config off, so that I can guarantee it will be going through the switch and rather than the router. So what I'm going to do on the router is I'm going to do an end, or do show IP interface brief. What that does now is I can look at the loopback. I know loopback is 2.2.2 and 10.32.56.1. Same thing with this guy. Do show IP interface brief. So now I know on FAS0/1 I have 10.32.56.2, which matches FA00, and I have 32.32.32.32 as the loopback, and on this guy I have that. So what I'm going to do is advertise certain routes, and this is what we're going to do. Is I'm going to go in and I'm going to do router Ospf 1, type in network. I'm going to type in 32.32.32.32.30, or yeah. Oh, I want to do my network. So 2.2.2.2, type in 0.0.0.0 and area 0. Now I've advertised that network. I'm also going to advertise the, I'm going to scroll it up here, network. It's 10.32.56.0 0.0.0.255 area 0. Now I've advertised those two networks. Now routes won't come up right away because this guy's not routing. So what I'm going to do is I'm going to do router Ospf PF1. That's right. Type in network and 32.32.32.32. It'll be 0.0.0.0 area 0. And then, because of the fact that I haven't advertised this network, routes won't come up. So it'll be network 10.32.56.0 0.0.0.255 area 0. Now that's I'll give it a minute before I freak out, but it should come up relatively quickly. And there they are. Now, how did I know that was going to work? Well, I didn't until just a couple hours ago when I was at work, and I was like, is this going to work? How do I fix this? You know, I don't feel like emailing somebody or spending hours online. I just went back through what I've been taught. So now, type in end, show IP route. Now, you see how it's only got one O route? What does that O route represent? That O route only represent, and you're only going to get those if there's a network behind you're directly connected. And the same thing with this guy. Show IP route. Notice how there's only one O route, and that is because I'm advertising the loopback. I'm advertising based on loopback. And I don't think I bet you any money that this guy is the DR. Show IP Ospf interface, and he is the BDR. I must have set the priorities ahead of time. Actually, no. If you do the show IP Ospf neighbor, oh, I did set the priority. I had to have set the priority. Show IP Ospf neighbor. Oh, I did it right then. Because I thought I would have. Let's do show run. Well, I didn't advertise it with a higher priority. How does that work? Interesting. Because this guy's 2.2.2.2 right here. And this guy's the DR. That's okay though. But now I'm going to go in and make sure that that happens. Because if they reload, if you reload the process, it will default back over to the other way, to where the higher loopback IP address will take over. So I'm going to go config T, type in interface loop 1, and type in IP Ospf priority is 100. That guarantees it. Okay. Same thing with this guy. Interface loop 1, IP Ospf priority is I'll put this one in is 10. So I can guarantee that it won't happen. Because if you do an N and you do clear IP Ospf process, it will relearn the neighbor. And the same thing with here. So show IP Ospf, like a type, neighbor. There, it still says. See how that worked? Show IP Ospf neighbor, and well, okay. That's it's goofed up now. Even though I went in there and changed the priority, it's still goofed. Because now it's saying that 32.32.32, which is DR, BDR. Yeah, it's saying that this guy is the clear IP Ospf process. Yes. There it goes. And then do the same thing again. Yeah, it's still saying that this guy's. Here's if you do show IP interface brief. 32.32.32 is saying this guy's a DR, and that's not the way it's supposed to be. What you can do is config T interface loop 1, type in IP Ospf priority, and then I will commit it as 1. The higher priority wins, typically. So, and then clear IP Ospf process. Yes. That should reset the other guy too here in a second. And it did. That's just not, I'm not liking that at all. show IP Ospf interface. Yeah, it's showing this guy's the BDR. Oh, you know why? Because I got it. I'm putting on the wrong interface. They're learning on the wrong one. That's why. See, that's why you do stuff like this, so you can figure it out. Config T interface fast0/0. Type in IP Ospf. That's my fault. Priority is 100. And then you do the same thing with this guy. Actually, it should work now. As soon as it clears. And 2.2.2 is the BDR. Still didn't do it. Config T interface. Because it's weird, it's neighbor ID. I'm putting it on. Wait a minute. Did I? The router is show IP interface brief. This is 2.2.2.2. Show run. Yeah, that's just weird that it's not doing that. And show run. Oh, wait a minute. That's why there's no. That's just not cool. Sometimes that's why sometimes going back and verifying is a good thing, because now there's no. I'll fix that. Config T interface loop 1 IP Ospf process or priority is 10 and write mem. Just do that for the fact. Write mem, and then we're gonna do a clear. I believe it's right there. Yes. So now it should figure it out now. And then we're going to do neighbor. And it's still learning it right now. There, that's what I was looking for. There we go. There we go. See, that's what was wrong. And this is some of the stuff that you have to pay attention to when you're, configuring stuff and going based on labs, to where if they tell you, I mean, that's more or less the only reason you would need it is in a lab environment, but the fact is that you know how to do it. It's changing the priority. That took me a long time to figure out. Not in this case, but that took me a long time to get, was the DR. And I was like, what the hell's the point of that? But, so, now we were doing that. Now we don't have any routes configured anywhere else because this isn't working yet. So, what I'm going to do is I'm going to cut the video there because we've been talking for 44 minutes. So you guys don't need to listen to me anymore. I want to get at least one more video done before I call it a night, or called it from here. So I'm going to make sure that frame relay is going to work before I kick off anything else. Now, what I could do is I could initiate layer 3 over here and just show you that, because that's a different situation. Eigrp doesn't have that type of a setup. What it does with Eigrp is, well, the point of Ospf is this is considered a border router because it borders another network. And actually, this connection right here is an ASBR because it goes to a different routing protocol. So this right here, it would be an ABR, an area border router. And these guys are going to exchange a different LSA, and that LSA type is going to go based on the fact that this guy is a border router. This guy right here is a backbone because it's routing, and because this guy knows how to get to show IP route. this guy knows how to get somewhere, but it's only to this router. So anything that's destined from here out, it'll know how to get there. So that's enough for me. This is a long video, but I just wanted to cover that and give you guys an idea of what to expect, what to see, and go from there. So I hope this has been informative for you, and I would like to thank you for viewing.